Hulk smash. Yeah, that's kind of what I felt like after grading some of these guys. I mean, kind of quite honest with you, and I'm sure some of you guys felt the same way. Trying to write this proof on the quiz because I kind of found out we fell into two categories. Either we had a really good sense what to do, or we didn't, and we're really kind of lost. So if you're looking at this video, I'm going to kind of assume you're in that second category. Didn't quite sure know what to do or how to proceed in this proof. But that's okay. That's why we're here. We're going to take care of it. So let us proceed. Get out of here, Hulk. All right. So just like before, I mean, we have to kind of follow a very definite order how we're going to do this. I talked about this in my first proof. If you need to watch that video, if not, let me talk about it right now. It all starts with a structure. It all starts with a diagram. Okay? The structure kind of builds us to a relationship. That relationship gets to some kind of equation. And then if necessary, we can actually substitute and solve that equation. And that's kind of like the sub-steps that are involved in all levels of this proof. Now, the whole point of starting with the structure is that we can't dispute it. If we jump right and start with the equation or the substitute and solve step, or in some cases, even the relationship, without acknowledging the structure, the diagram itself, that gives us a point to argue. Like if you just say, hey, a measurement of A plus a measurement of C equals 180, sorry, I shouldn't say that, but the measurement of A plus a measurement of D equals 180 degrees, well, how in the world do you know that? What went on in your head that said that's actually going to be true? That's because you didn't start with a structure, and that's really the key to writing a good proof and writing kind of a shoddy proof, is that a good proof starts with the structure. A shoddy proof kind of jumps right into some of these steps that our minds are going to right away. So as we're going to proceed and write this, look at our givens. In fact, I'm going to write them into our diagram as we go. Measurement of A is 100 degrees. And measurement of H is 80 degrees. And we have to prove D and F are actually congruent. Now, they're not equal. They're congruent, which means, yeah, we have to prove probably the measurements are the same. To do that, well, I think we can build a really quick plan in our heads. If we can take this 100 degrees up here and show that D has to be 80, and then if we could take this 80 degrees on H and show that F has to be 80, then if the measurements are the same, we know they're congruent. And I think we kind of identified the basic steps of our proof. We have to show D is first 80 degrees, show F is going to be 80 degrees, and if they're equal, it's got to be congruent. But again, we got to think in our heads, start with the structure, then build the relationship equation, and then substitute and solve if we need to do that. Right? Now, another thing I want to try to talk about as I'm kind of going through this proof is efficiency. That's something that we weren't good at on this proof if you didn't get full points. Meaning, when I say efficiency, I mean, can we get there, or are you trying to get there in the fewest number of steps possible, or you kind of lollygag and you kind of going around in circles? Now, if you got an answer, if you actually wrote a very nice proof and got full points or maybe a 3, as a rating, that tells me you got the answer, but doesn't tell me necessarily that, or didn't tell you necessarily you got there in the fewest number of steps. Guys, this can actually be done in like 5 or less steps, and I'm going to kind of try to demonstrate that to you. So moving forward, think, am I getting this done in the shortest amount of steps possible? If not, and you probably go back and do some planning first. Make sure I have a plan clear in my mind of how I'm going to get to my answer before I start writing the proof. I know that's not always going to be our natural process, but guys, that's the case. We got to start doing it. So very first thing I'm going to do is write in my givens. And guys, again, quick disclaimer, I'm going to do this in a kind of different style, or in kind of my own style. It might not be the style you chose to write it in, but it's going to be a style. And that's the other thing that we have to kind of think about moving forward, is making sure that we're neat and orderly in our work. Because I'll tell you right now, nobody wants to read a proof that's poorly written and that's messy and it's kind of jumbled and all over the place. We got to keep things kind of very ordered, very neat. So I'm going to try to write a proof kind of as a list. And I mean, if anything, I'm going to kind of separate this into 2 columns as I'm doing my work. In the kind of this first column on my left, I'm going to write all my statements. So it's kind of like the claims I'm making. Over here, I'm going to write my justifications. Justifications. In other words, it's going to be kind of my reasons why. Or it's going to be like the becauses. So if you kind of remember, like, this is happening, and I always ask, like, because, that's what I'm going to put over my justification steps. Let me kind of clean up my area a little bit, talk about neatness. Okay? So the very first thing I should probably write in my proof, the very first statement I think I need to make are my given statements. So I know right off the bat that the measurement of angle A is equal to 100 degrees, and the measurement of angle H is equal to 80 degrees. And the reason I know that is because they are given to me. Again, notice I'm kind of keeping things labeled. I'm actually going to number my steps here. I'm just not going to write it in kind of a crazy mess. I'm going to try to keep it neat. So the first thing I'm going to try to do is try to get angle D to be 80 degrees. But again, I just can't jump there. I just can't make that claim. Otherwise, I'm not going to be able to defend myself when people are reading this. Because the first thing I'm going to ask, if I just say, hey, the measurement of angle D is 80 degrees, is why? Well, why do you know it's 80 degrees? But if I start with, say, the structure, if I start up here with the structure of that, and we just have to live with that line, I'm not going to bother to, well, maybe I can erase it. If we start with the structure, if we start with the diagram, then that's really going to be indisputable. So yes, I need this angle D to be 80 degrees, but first I need to talk about how angle D and angle A are related in the structure of the diagram. And the way I know they're related is that they form a line. So if they form a line, I know angle A and angle D are supplementary. And the reason I know that is the linear pair postulate. So I've identified the structure being linear pairs. The result of the relationship is that they're supplementary. Now that I know the relationship, I can probably write it into some kind of equation. Again, I'm not going to jump the gun and put in numbers. I'm just going to write the equation that I know is always going to be true, which is if I add an angle, measurement of angle A, and then add the measurement of angle D, that's going to be equal to 180 degrees. And I know that because that's the definition of supplementary. Okay, so I am maintaining my chain. If they're supplementary, then they're equal to 180 degrees. Now that I have my equation, I can now do some substitution and solving. If measurement angle A plus measurement angle D equals 180 degrees, then it has to be true that 100 degrees plus the measurement of angle D is equal to 180 degrees. And that's substitution. I took out A, I put in 100, that comes from my given step. Now this style of proof is different. I'm not drawing arrows or anything. I'm just simply making statements and changing statements as I go, making sure everything's labeled. So I did this because of substitution. Okay. So now I have this statement. I can now conclude that the measurement of angle D has to equal 80 degrees, and that's by solving. Okay. So I'm halfway there. I've now got an angle D to be 80 degrees. Now I just got to show F is 80 degrees too. But again, I can't jump there. I just can't say, hey, it's 80 degrees. I have to build the structure first. From the structure, go to the relationship. From the relationship, then do my substitution solving. And to make it easier on us guys, I'm going to change colors too. So if I think about F and H, the angles themselves, and think about the structure they're in, I would claim that these two are vertical. So I know if they're vertical, they have to be congruent. That's my structure. That's the relationship, I get from my structure. So angle H is going to be congruent to angle F. Okay. Now again, another problem we saw kind of consistently is that we have a mixing of symbols. We're talking about congruency. We're not talking about the measurements. Measurements are reserved for equality statements. Notice that the M showed up when I was talking about an equals, an actual number equation. If I'm talking about the angles themselves, I'm talking congruency. So angle H is congruent to angle F, and that's going to be because of the vertical angle theorem. That's what it states. The vertical angle theorem says if I have angles that are vertical, they are congruent. Well, if they're congruent, then I know that the measurements are the same. So the measurement of angle H is now equal to the measurement of angle F, and that comes from the definition of congruency. Okay? So again, notice we're now using the correct symbols here. We are using the correct symbols here. Measurements have to do with equality. Angles themselves have to do with congruency. Now, these two statements are interrelated. If they are congruent, the measurements are the same. If the measurements are the same, the structures are congruent, which we're going to use later on. So please keep that in mind. Well, if I have this statement, I also know H is 80 degrees, then I can just say 80 degrees is the same thing as a measurement angle F, and I know that by substitution. Okay, so now that I know that they're both going to be 80 degrees, here angle D is 80, and angle F is 80, I can claim right then and there, if the measurements are the same, they have to be congruent. So angle D is now congruent to angle F. And I'm going to claim, actually, same thing I claimed up here. That's what it means to be congruent. If they are, the measurements are the same, the statements are congruent. I'm sorry, the angles are congruent. If the angles are congruent, the measurements are the same. That's the end of the proof. That's how we get to there, guys. So a little bit different proof that we're asked to work, because in the past we did a lot of trying to find something to be an actual value. This is a little bit different, but certainly in play. Now, I blew up a lot of the steps, but hopefully you guys are seeing it came in 3 big chunks. We have the first step trying to get D to be 80 degrees, the second chunk trying to get F to be 80 degrees, and the last one actually putting them together. Okay. So I hope this helps. Hope you guys are now kind of thinking about how to organize your proof, take it slow, write it in a way that's easy to read, and also please, oh please, make sure you're going to the diagram first and getting a relationship from the diagram, but using that diagram or the relationship from the diagram to give you a nice general equation, and then substitute and solve in the very last step. That always comes last. You guys gotta have to stop putting that first. So I hope this helps. We'll be looking at the second proof in the next video.